There is one more manipulation I should have done here. Putting all this over a common denominator, this exponent becomes m plus n minus 1 over m, and that should have been obvious since all these denominators are m. I didn't need to go to this step at all. I could have just directly gone from here to here. But with that, now we see that our form, we have a v to the 1 power, mp of t as the coefficient, mq of t times v to this power. And when we write that out, it looks like this. Now that's progress. The left-hand side is in the form of a linear, first-order linear equation. We know how to deal with that. We know what our integrating factor is going to be. The problem is this thing still has a v to some power here. So what are we going to do about that? Well, wouldn't it be nice if this thing would just go away? And is there a way we can make it go away? Well, yeah, we can make this go away. Remember that m was not yet specified. M can take any value, including the value that makes this exponent 0. So m can be anything, including 1 minus n. So that v to the m plus n minus 1 over m equals v to the m to the 1 minus n plus n minus 1 over m, well, over 1 minus n if we like, but that doesn't matter, which is v to the 0, which is 1. So if we simply let m equal 1 minus n, we wipe out this term, and we have a first-order linear equation. So we'll just write down, let m equal 1 minus n, so v to the m plus n minus 1 over m equals 1, and our equation magically transforms into v prime plus, now we're going to let m be 1 minus n, so we're going to have 1 minus n here, p of t v equals m, which will be again, let's try to make this into 1, 1. Let's just wipe it out. We got room for $1 here. Okay, equals quantity 1 minus n q of t. This is first order linear homogeneous. We'll have an integrating factor, which is going to be e to the integral of 1 minus np of t. Going to get a left-hand side in the form of a derivative, right-hand side hopefully in the form of something we can integrate. Now there's no point in going further with the symbolic solution. We'll simply look at a couple of examples and see how this works out in practice. But this is the general process we'll use to solve a Bernoulli equation, an equation of this form.